I want to have a quick explore of the language of chance. So I want to start off by looking at this idea that we can describe events, probability, or the chance events happen on a bit of a continuum. And I'm starting off with a continuum from impossible through to certain. And so here I am, I'm at the impossible end here, and I'm drawing snowflakes. Yes, they're snowflakes. And the reason I'm drawing snowflakes is because I think it's pretty much impossible that I will see snow tomorrow, given I live on the mid-north coast of New South Wales and it's the first day of spring tomorrow. So impossible is my first one. It just won't happen. Next language would be the idea of being highly unlikely. So if I'm going to take my deck of cards and cut it, I think it's highly unlikely that I'll see the ace of hearts. Nine of hearts, got a heart, that's good, but not the ace of hearts. And the reason I'm saying that's highly unlikely is because there's only one ace of hearts in the deck of 52 cards. So I'm saying really slim chance that occurring. Now if I take a dice and I want to roll dice and I say, well, what's the chance of me getting a 6? Like there, it's a 3. I would have said that's unlikely. It's not highly unlikely, it's just unlikely to happen the first time I roll the dice. There's only one 6 out of 6 different combinations. If I move along a little bit further into an event that you'd be familiar with, and that would be tossing a coin, heads or tails. So if I toss that coin, the probability of getting tails, there you go, got tails. The probability of getting tails, or the chance of getting tails, I would have said was even. There are only two things that could have happened, heads or tails, and so that's an even chance. Moving on a little bit further, beyond even, the chance that I'll get a number greater than 2 when I roll this dice. There's 4 numbers greater than 2. Bingo. I would have said that was likely to happen. There was more chance of it happening than not happening. Moving over here, good old game of Twister, and using the Twister wheel, spinning the wheel, what's the chance it won't land on yellow? I would have said that's highly likely to happen, to not land on yellow, given that just about the majority of them are not yellow and there's only a couple of yellows on there. So that's highly likely. Now to get an event that's certain, well, what would be nice is to always get a 6 when I roll the dice in some games. So if I did that, I'd need to design myself a new dice. And so designing a new dice, 6-sided dice, here's the net of my dice, and putting a 6 on each side. And suddenly if I followed that up, made a dice and rolled it, I would be certain to get a 6. And so that's the language of chance, some of the terms we use to describe the chances of events occurring. So building on from what we just looked at, that language of chance, I want to look at the idea of random events. And they're ones where every outcome has an equal chance of occurring. So a couple of random events from those last lot of experiments I showed you. The first one would be the coin. If you toss a coin, there's 2 possibilities that can happen. They're both equally likely. It's equally likely to get heads as it is to get tails. If you roll a dice, each side of the dice, and as long as it's not a biased dice, is equally likely to come up 1 to 6. So these events are random events, and there are times when we want random events, and obviously in games of chance we'd like them. Sometimes it's not appropriate to have random events, such as picking a sporting team. If you've got 30 people trialling for it, you can only pick 11. You don't want to use random events. You want to find the 11 best for your team. Sometimes, rather than having random, you might like to build some bias into your events. So a bias gives one particular chance more likelihood of occurring. So, for instance, if I was looking at a dice and I wanted to make a biased dice, and I wanted to make my dice come up more often with 1 than it would any other number, then what I could do is I could use 1 on there twice. And now I have a dice that's biased towards 1. Not every event has an equal chance of occurring. It's more likely for 1 to come up than any other number there.